Okay.
Now we have with us Thirumalai. He is Cloud Solutions Engineer at Singapore, and he'll be talking about cloud runs from code to serverless with containers. So let's hear it from him.
Thank you. Can you hear me? Okay, all the way at the back. Thank you very much for that introduction. Just a little bit of clarification. I'm not actually from Singapore. I'm from Malaysia. But yeah, that's okay. There we go. So it's good to be here, especially. Or I mean, I should have been back home celebrating Merdeka, but you know, it is what it is. Right. Is everyone having a good time so far today? Yes. Okay, awesome. So I know it's been a long day. I know my talk is at 4:30, so I will try my best not to put you all to sleep. If you all sleep, then I can quit my day job. Yes, so let's move along. And this should start working. There we go. So, okay, just to get a show of hands, who here is a developer? Okay, anyone in DevOps? Okay, cool. So most of you are developers then. Right, so this talk is 100% buzzword compliant. So you will hear me talking a lot about serverless and serverless. So feel free to also stop and ask me questions whenever there is something that you don't quite follow. You don't necessarily have to wait till the end, okay? Cool. So what is serverless? Is it actually another buzzword like big data, or is there something actually behind serverless? It's a real misnomer, the term serverless, because people usually have this idea that serverless does not actually have any servers associated with it, but there is a lot of services and servers that actually need to be provisioned and managed in the background before something like serverless actually comes to fruition. Okay? So at Google, we have a way that we'd like to think about serverless, and from an operational perspective, we would want the people who use our serverless services to not worry about infrastructure, right? So no managing of the actual server. You don't have to buy server X. You don't have to even provision VMs from within the cloud environment if you're using a cloud environment. You don't have to worry about security because the provider takes care of security. You would ideally like only to pay for whatever that you use. So that is kind of like the base premise of any cloud operating model, that you pay only for whatever that you use, right? Make sense so far? Cool. Now, from a developer's perspective, we feel that serverless environment should allow you to create applications based on services. So traditionally, or at least a long time ago, companies used to develop apps like monoliths. Is everyone familiar with the difference between monoliths and microservices? Yeah? Who runs or who develops microservices in their day job? Anyone? Okay, cool. And then because we always associate serverless with something lightweight, something that can easily run, we also want it to be event driven. So for anyone who's familiar with AWS Lambda is a very event driven architecture. So it's not like your it's essentially functions. Let's just put it that way. And it has to be open. So we don't want you to be locked into a specific platform like AWS Lambda. So we know a thing or two about serverless. Can anyone tell me what these two logos mean? Or has anyone used either one of these services before? Do you know what it's called? Okay, so the one on the left is Cloud Functions, and the one on the right is App Engine. So for anyone who has used Heroku is very similar to, or rather App Engine is very similar to Heroku. And App Engine is platform as a service, and Cloud Functions is functions as a service. Right? Just moving along from just those two compute options, our entire stack actually has some form of serverless or other. We have an entirely serverless data pipeline. We have serverless storage, serverless compute, serverless Google Assistant, serverless machine learning. Pretty much anything in the Google Cloud Platform stack is actually serverless, with the exception of things like Kubernetes and compute, actual virtual machines, right? Any questions so far? Yes?
You said about the two logos that you showed us.
Yeah.
That one, yeah. So the one on the left is the second function.
Yes.
And the other one, app.
App Engine.
So do we really need to have this? Actually, because an app is several functions. So thank you.
Yeah.
So how come did you have this too? I mean, why going through app if you can just build several functions
Okay.
completely and decouple them?
Okay. So App Engine is more for a complete application, in the sense of it's an actual web application that takes a response, does some processing, and then gives you back a response. So things like for example, you can host an entire web app with multiple services in App Engine itself using different languages. And again, you are definitely right in the sense that both of them do fairly similar things, but Cloud Functions is for very small purposes. Like for example, you can trigger a Cloud Function to watermark an image once it has been uploaded to something like cloud storage, right? Or you can tag that image with certain characteristics by passing it to a machine learning or cloud vision API, for example. So really, really simple event-triggered activities
For
like
processing.
yes, can be run really well with functions as opposed to in a full web app. I'm not saying that you can't do that. You can, but it's more efficient this way. Does that answer your question?
Yeah.
Okay, cool.
Definitely, thanks.
Cool. Right, moving along. So in my actual day job, yes, sure.
The cloud functions. Which hardware do you run these cloud functions on?
We don't actually have hardware per se that runs Cloud Functions. It actually uses something internally that we call Borg. Borg is our container orchestration platform. So anything and everything that actually runs inside Google, including Gmail, whatever, all of it runs on Borg. And when you create a function, it uses a section of Borg and runs those functions.
Eventually, Borg would run on
Hardware.
platform, right?
Yeah, so it's from, are you talking about our data center hardware?
Yeah. Right.
Okay, so it's all custom built.
No, why I'm asking this is, if you look at Amazon, right?
Yeah.
They have this micro servers, right?
Yep.
So, how far you are away from that, or your cloud functions are better than that? So that's my question.
I wouldn't say that they are better or worse. It's a very politically correct answer, because they do different things and they have different levels of control. So it's ultimately up to you what you want to use them for. So if you find that Cloud Functions or even Lambda, so Cloud Functions and Lambda are equivalent, more or less equivalent. Lambda does support more languages than we do, but ultimately it's still the same thing. And if that suits whatever that you are trying to do, then yes, great. But from a micro VM perspective, we don't have any of those yet because Google's strategy is more focused and towards containers as opposed to running things on virtual machines. Yeah.
So, I mean, that's the reason maybe it runs on any type of hardware, right? You support it on any, I mean, so that it can be run on any type of hardware.
Yes.
So that's why you are not going towards a micro VM kind of concept.
No, that's true. So later on, I'm going to be talking about something called Knative, which is actually the foundation for Cloud Run.
Okay.
Yeah. Yes.
Guys, I'm really sorry. Can we please save the questions for the end so
Okay,
that
maybe.
we can at least go through the entire content?
Maybe I should have said that. Anyway, so in my day job, I actually need to sell GCP, but I'm not going to try and sell GCP to any of you today. So if I do, it's a force of habit. Right, so serverless is more than just writing code. There's a lot of different components that need to come together to actually achieve what you would consider serverless. So we need to bring in compute, we need to bring in storage, we need to bring in a lot of different messaging components before something like Cloud Functions actually happens. Right, when we first created App Engine and Cloud Functions, we had customers asking about how they can bring in existing binaries or old binaries like Python 1.3, for example. And you know, people started asking, do I actually have to choose between containers? Can't I just run everything as a serverless manner? And you know, App Engine is fairly proprietary. Even though you just write your code and upload it, it's still a proprietary engine. It's not open source. So people were still concerned that they would be locked into our platform. And we don't want that because Google has always been a proponent of open source and no vendor lock-in. Okay? So what sort of use cases would we use serverless for? If your application is publicly accessible, then you could use it for a web app. You could use it as some sort of mobile backend, an API backend, some webhook or something like that. And if it's an internal system, then it could be a microservice, it could be an asynchronous task, and what have you. Right? Speaking of microservices, we can't have a conversation about microservices without talking about containers. So, who uses Docker? Okay, cool. And so the good thing about containers is it solves the problem of it worked on my machine, it's not working when I'm deploying it, and all of those things which we all have heard before. You can use any language because what you're essentially doing is you're packaging your language, your binary, and your application, your binaries, and other libraries inside a container, and you let the container runtime do everything else. As I said, any library, any binary, there's a ton of base images from things like Nginx, Redis, you name it, everything is available as a container right now. And finally, containers are industry standard. Has anyone heard of the OCI, the Open Container Initiative? Okay, so the sorry? Okay. So the OCI is actually an industry standard that aims to standardize container image formats across the board so that you can actually develop multiple applications to run and orchestrate containers. Okay, since pretty much everyone knows what containers are, I'm probably going to skip this, but just for completeness sake, on the left we have virtual machines, traditional VMs where it's just the shared hardware, but the operating system is packaged into a virtual server, and then it's every kernel will be different, right? And on the container side, the kernel is shared, the operating system is shared, and then you only have isolated binaries and applications. Okay. Right. Has anyone been to a Google talk before about containers? Have you seen this information before? Okay, so the reason why I put this up here is because Google, as I keep mentioning, has been a very vocal proponent of containers, and everything internally runs on some form of container. Google actually initially came up with the LXC initiative, Linux Containers Initiative, and pretty much everything runs inside a container. So even compute engine, when you provision a VM, that gets provisioned inside a container within Bog. So Bog is, speaking of Bog, does anyone watch Star Trek? Star Trek? Anyone else? Okay, so you know the aliens Bog, right? The Bog alien. So anyway, bad joke. Right, very nerdy joke even. So we launch 4 billion containers every week, and we know a thing or two about containers. So just containers alone are not enough, because we need to solve problems like scaling, we need to solve orchestration, health checks, monitoring, and a whole bunch of other things before we can actually use containers as a viable application platform. So how do we do that? And we have Kubernetes. Kubernetes is the platform to orchestrate and run containers. Does anyone use Kubernetes? Okay, cool. Do you find working with Kubernetes easy? I'll definitely answer that question in a bit. So from an operator's perspective, Kubernetes is it takes care of all of these things. It takes care of container scheduling, monitoring, storage, load balancing, service discovery, and things like that. And the best platform to run Kubernetes on, in my unbiased opinion, is Google Kubernetes Engine. I really mean it, totally unbiased. And from a developer perspective, it's not the right platform because it doesn't give you the best abstraction for an end developer experience. But when you are building an application or building a system, it's a great platform to do it, because you can think of Kubernetes as being a data center in a box, right? It takes care of networking, it takes care of monitoring, it takes care of self-healing, it takes care of so many different things that you don't actually have to worry about that. But the problem is, when it comes to Kubernetes, once you install it, managing all of that is a whole other headache that you have to deal with on a day-to-day basis, and you need a dedicated team just to manage Kubernetes. As a developer, as a small organization, maybe as a startup, you don't want to deal with all of that. So when, as a developer, you want to use Kubernetes, you need to write your code, you need to build the Docker image, you need to do all of those things. But what do you actually want to do? All you want to do is just write code. So, do developers want to use Kubernetes? No, definitely not. So, as a developer, you want serverless. When I say serverless, you just want to write your code, you want to use your favorite language, you don't want to manage the infrastructure. As a sysadmin, as a so-called DevOps person, you want to orchestrate those services. You want all of those nice features, and how do these two work together? Now would be a great time to make a DevOps joke, but I think this makes the joke for itself. So we can still do serverless while using Kubernetes. How? That's where Knative comes in. So Knative is an open source project that we can use to build serverless platforms on top of Kubernetes. It gives you a set of building blocks to construct your own Google Cloud Functions or your own Lambda. Ultimately, it is still an abstraction on top of Kubernetes, because it builds all of these layers on top of Kubernetes, including Istio. Does anyone know what Istio is? Yeah? So without Istio, Knative doesn't work. But we don't tell you that because Kubernetes is already complicated. Istio adds another layer of complication. Knative is as complicated as Istio. So we don't really want all of these things to scare you. So we just tell you that Knative is easy, but actually it's not. What can you do with Knative? As a developer, you can deploy things. As an operator, you can make your devs' life easier. And if you want to build your own platform like Heroku, you can go ahead and do that too. Right? Make sense so far? Cool. So this is kind of like the workflow, or at least at a high level, what it would look like. As a dev, you either want to use your functions as a service, or you build something on your own. But at the bottom, you still have Knative, and even below that, you have Kubernetes. Okay? But no, all you want to do is deploy your code, and you would want to deploy it on the cloud, or at least I hope you want to deploy it on the cloud. Because if you don't, then my talk becomes meaningless. There we have Cloud Run, which is essentially Knative on the cloud. So all you do is just you code. You still have to build the container. Obviously, you can't get away from building. I don't know. Maybe next year we'll come up with a new service that just lets you go from code to run. Anyway, too early for that. So the build process, you are familiar with Docker build. For those of you who use Docker, I think you are familiar with these commands. You might be wondering what GCR is. GCR is our container registry. For those of you who are using containers, you might be using ECR, which is Amazon's container registry, or even Docker Hub as well. So GCR is our version of Docker Hub. We have something called Cloud Build. Cloud Build is a managed build platform, not unlike Jenkins and any other CI tool that you have. Jib is something open source that we released last year or the year before that to build Java containers. I'm just including it here for completeness. You may or may not want to use it. And then there's something called build packs. Is anyone familiar with the CNCF, Container Native Computing Foundation? So the CNCF is a standards organization that is the custodian for all of these open source projects that you are familiar with, things like Kubernetes, things like Knative, and a lot of different open source projects that form the cloud native infrastructure and service mesh and things like that. So they have something called the CNCF landscape, and build packs is a tool that allows you to build containers to the OCI standard. Okay, so you can use build packs, and when you build them, the container images that you get are OCI compliant. Okay, and finally, you do your traditional CI/CD with Jenkins, Circle CI, TeamCD, what have you. Does anyone use Jenkins? Okay. Now, let's go to how do we run your container. So once you build it, you upload it to the container registry. You have a URL, gcr.io/whatever, and all it takes in Cloud Run is just for you to point to your container image, and Cloud Run instantiates the container and gives you a URL that you can access it through HTTP. And it also gives you a free SSL cert that ensures that your container is accessible only through SSL. And it supposedly takes a very short amount of time, which I will hopefully show you in the demo. Yep.
Sorry, I'll wait.
No, it's fine. Go ahead. If it's a quick question.
I was just curious about performance.
Right.
Startup, for example.
Cold starts.
Yes, exactly.
Okay.
How do you deal with the issue of cold starts, especially for like JVM languages, which are
Right.
cold starts?
Okay. So you can use things like Spring Boot, for example, because Spring Boot is really lean, right? But ideally, you don't want to be using a very large container for this. You want to try and keep it as lean as possible to avoid long startup times. In any case, it doesn't take longer than 30 seconds for it to actually get to that, get to a stage where it starts to run. Yeah, even on heavy containers. Yeah. I'll show you the demo. Then maybe it makes a little bit more sense. Right, so as I said, it gives you this URL which you can then customize as well. It integrates with Firebase hosting, and it's secured with SSL. Okay, so this is kind of important because Cloud Run, since it uses Knative, it has to comply with the Knative container contract. And what that means is you are only allowed to use stateless containers. You can't use stateful containers. It has to listen to HTTP requests on a specific port, which is 8080 at this time. So internally, the container would listen on 8080, but externally, it's exposed on 443 because it's SSL. And it does not use any CPU outside of when it's handling a request. So this is also fairly important because this forms the basis of pay-as-you-go, right? It uses something called gvisor. I'm guessing for those of you who are familiar with Docker that you would know the concept of a container runtime. So if you look at it from a VM perspective, a container runtime is the hypervisor that runs the operating system that abstracts the hardware away. The container runtime is the same layer of abstraction that abstracts the kernel from the application. Okay? So gvisor is an open source container runtime that Google released. Yes, no prizes for guessing that because it's G. And the difference between the Docker runtime and gvisor is gvisor gives you a very good level of isolation. Containers have always had a bad rap because they tend to leak memory, and you can, if you get access to things like user space memory on a server, you can essentially extract all of the information from the container, and that's a significant security risk. gvisor tries to avoid that. Okay? Make sense? Because it's all based on Knative as well, we have something called the Knative resource model, and the Knative resource model is a layer of abstraction on top of a GCP project where we only look at specific services, and these services can then be split into revisions, and each revision will then handle its own container instance. Okay? And the service object also exposes route and configuration information. So without actually going into too much detail about Knative, because it's more of a Cloud Run presentation than a Knative one, routes and configurations basically handle the sort of like history behind the different revisions of a container, and also how that container is meant to be run, and what is the path that leads to the container, essentially. Okay? I know that didn't make very much sense. I'm sorry. Right. So some popular products that have been that are fairly popular these days that use Knative is Cloud Run. Obviously, you can use OpenShift on top of Knative, and also other platforms as well. This is how the Knative serving API looks like. For anyone who has used Kubernetes, you know YAML files are the base manifest for all things Kubernetes. And since at the very bottom it's still Kubernetes, everything is based on a YAML file. Right? We have 4 regions at the moment. More regions are coming up. At the moment, the service is still in beta, so it's fairly limited in what it can do. But if you want your service to be global, then you can deploy it in any of these 4 regions. Right. You can have Cloud Run as a public service, so it does not need to be authenticated. All you do is just hit the HTTP endpoint and it will give you a response. You can have it as a private service where you need to provide an authorization header before it accepts your response. You can push events from PubSub. Does anyone use a message queue? What do you use? Nice. So PubSub is very similar to Kafka. And so you can push events from PubSub and have it invoke the Cloud Run service. Cloud Tasks is another service that we have. It's essentially asynchronous tasks that can be, I think the Azure equivalent is something I can't remember, but it's for asynchronous tasks. Cloud Scheduler is managed cron, so you can trigger Cloud Run to run based on a particular schedule. So earlier there was a question around cold starts. So concurrency is the problem, or at least it's the solution to cold starts, because we can have multiple requests that go into every single container. So this kind of avoids the issue of cold starts because the container can accept more than one request at a time. Having said that, you still do have that problem of cold starts because Cloud Run does scale down to 0. So when there is absolutely no requests, it does still take a little bit of time to start up for the first time. So this is a comparison of how Cloud Run works with concurrency and without concurrency. The green line is a competing product. I'm not going to name what product it is, but it's a competing product. So with concurrency, you can see that the number of instances for Cloud Run, number of containers for Cloud Run is significantly lower than when you disable concurrency. Right? Has anyone used GCP before? Google Cloud? Okay, wow. How about AWS?
I mean, not at work, just personally. I've been playing with it, but never deploying anything for work.
Okay. Okay, so clearly Google needs to do a better job. So Stackdriver is our monitoring solution. It's kind of like AWS CloudWatch. So Cloud Run and pretty much every Google service is integrated very deeply with Stackdriver. Stackdriver also has the added benefit of being able to monitor AWS resources as well. So for those of you who are interested in adopting multiple clouds for your applications, this would be a great fit. We talked about pay-per-use a little bit earlier, and Cloud Run pricing is on a sub-second, actually 100 millisecond level, so it only charges you based on 100 millisecond blocks. So if, for example, the container takes 200 milliseconds to run, you get charged for 200 milliseconds. If it takes 50 milliseconds to run, you are charged 100 milliseconds. Okay? Right, so let's look at how billing would work. So let's say you get one request and then that request ends, and then you get a second request and that request ends slightly later than the first one. So you would be paying for the time from the first request start to the end of the second request. Does this make sense? Okay. Any questions? Yeah.
So is it not like Lambda where every request gets its own process or instance?
Yeah.
You can actually send multiple, or you can route multiple requests to the same context.
No, I don't.
Sorry, I'm just curious. It sounds like this is very different from Lambda, where essentially each Lambda process gets one request, one response.
Yes.
It sounds like here we can actually route multiple.
Yes. So that was concurrency. So you can actually hit multiple requests to the same container instance, and you are charged based on how long that container runs. Yeah. Okay, so Cloud Run as a managed service is only limited to one vCPU at this time. You don't get access to GPUs. For example, if you want to run any machine learning workloads, you can't do that just yet. Cloud SQL is our managed version of MySQL and Postgres. So we only recently launched SQL Access, and obviously the other features are not available yet. And if you want some more features, the solution is Cloud Run on GKE. So what is Cloud Run on GKE? It's exactly the same Cloud Run that I've been rambling about for the last I don't know how long, but it runs on top of Kubernetes, right? You get more control. You do need someone to manage it because you are managing a Kubernetes cluster. If you are quite familiar with Kubernetes, then all of the policy controls and other management manifests that you have, you can reuse them. You can run Cloud Run on GKE on custom nodes. You can use GPUs, and it's essentially just automated installation of vanilla Knative on top of Kubernetes. Right. Sorry? No, not yet, because the TPUs actually need to have their own VM, and that VM is directly linked to the TPU. So if you want to run any TensorFlow jobs on a TPU, you need to use a VM. You can't use Kubernetes for it just yet. So this GPU that I'm talking about, the GPU is attached to the cluster. Yeah, so it's local to the cluster. Okay, right. Same thing. It scales down to 0, integrates with other services. There is an integrated service mesh because of Istio, and all of the other functionalities are still there. The only disadvantage is that you need to manage your Kubernetes cluster. Okay, so just to recap, Cloud Run gives you a Docker image as a service, scales, gives you multiple route support, deploys fast, hopefully, and it is only pay-per-use. Cool. So just again, this is more of a sales pitch. We have Cloud Functions, App Engine, and Cloud Run, and these are the different reasons why you should be using any of these services. Right? So let me see if I can do a demo. All right? This is usually how it goes, most of my demos. Right, okay. So I have this little Go program here. Can you see it? Actually, the code doesn't really matter. It's just extremely simple. So I'm going to make a change. And I am going to so when I do this git push, right, now is the best time for an error to happen, and I know why. Hang on. So when I do this git push, right, what happens is I have a cloud build trigger already enabled that listens to any changes that I do on my GitHub repo, and it automatically creates a trigger, automatically builds the container. So you can see that it's now building this. So before I actually go into Cloud Run, let me just show you this for a short while. And this is essentially just managed Docker build, okay? And once it's done, it will actually create this container. And I can see that new container in my container registry here. And it was uploaded just now, right? So now let's see how easy it is to run it on Cloud Run. So this is the Cloud Run interface. For those of you who have not seen GCP before, this is how the console looks like. All I need to do is just click here, create a service, and select the container image. In this case, this one, right? I then choose where I want to run it. So these are the different regions where I have that service running. So I'm going to choose Asia Northeast. Oops. I use a service name, and earlier we were talking about private and public facing URLs. So I'm going to choose the public one because I don't have a service account configured, and then I can just click create. Okay, so that's it. It deployed, and I can just click that, and there we go. That's how easy it is to create an application and run it. Okay, since we're out of time, I actually have a much longer demo, but yeah, since we ran out of time, I'm going to skip this and say thank you very much for your attention, and I'm done. And if you want to use Cloud Run, please go to that link. And also, if you have any other questions, I'm more than happy to answer them. All right, thank you.
Now kind of shoot those questions which you have been holding back.
Or if you haven't.
No? No questions?
Yeah. Oh.
The concurrent functions, right? You charge based on, for 2 requests it would be just the time it runs, right? So, but you are charging on the container, right? So would it be more compared to Lambda functions where the 2 requests would be charged only on micro VM based requests?
It depends on how long the request runs for, because Lambda also charges in a similar fashion as well. It based on yes.
So in this case with concurrent functions, you meant to say that even if it is like concurrent, it would be using 2 cores, right, to run?
No. It's not multi-threaded. It's concurrent. So it's still running on that single vCPU. It just parallelizes the requests and responses. So in a manner of speaking, you can imagine it to be a single virtual machine, let's say running Apache, for example, or Nginx or something like that, that is serving multiple web pages to a variety of different users who are accessing it. So that's essentially what it is. With Lambda, you are kind of like creating a micro VM for every request that comes in. So that would obviously be more resource intensive. It may not necessarily take longer or shorter, but it's a less efficient way of using the limited amount of computing power that you have.
So you mean like time slices?
No, time slices would be for functions. For Knative, it doesn't work that way. Knative is just the entire period of time where that container is actually active for. So let's say you hit the container with 80 requests, right? 80 concurrent requests, and it takes 5 seconds for all of those to actually finish running. So you get charged only for that 5 seconds. Sorry?
So how is it now?
How is it concurrent? So all 80 requests get served by the same instance.
How does it happen internally? Just right.
It's
So it doesn't spawn a separate thread kind of.
No.
Right? So,
So-
how does it happen?
so okay. How we're not actually looking at it from the application itself, right? It's more from the HTTP endpoint up to the container. So whether or not your application is multi-threaded is irrelevant, because we are not doing concurrency on the application level. We are talking about concurrency on the container level. So what that means is Cloud Run, essentially the load balancer gives a maximum of 80 requests to that one container instance. So for example, if you have, let's say, 240 requests per second, it would spawn 3, because then you would get 80 in one container, another 80 in container number 2, and the third 80 in container number 3. That's what that means. Does that make sense?
So you're telling that there are multiple containers which will be spawned.
Yes.
Satisfy this requirement.
Yes.
Right?
Yes. So the maximum with managed Cloud Run is 80 concurrent requests. Yeah.
We are almost on the time. Maybe I have to prepare for a panel.
Sure.
If you have a question, can you please take it outside the room? Thank you so much
Okay.
for answering so many
Thank you.
questions. Please give a huge round of applause for Thirumalai.
Thank you.